Okay, hello everyone. I hope you are happy and healthy. It's weird because like a couple of your friends are here, the rest are online and some are asynchronous. So today we keep working on the concept. Then we have our first lab today, which we install Hadoop and learn how to work with. So for you guys that are in the class, I think I have a good time for helping you guys. So for you guys, since I want you to have a more productive lab, so let me tell you one thing. Go to for you guys that are here, please go to slide page 37. I put 3 download links. You have Mac, you don't need to download the third one. Oh, somebody. Okay, sorry. Let me put on mask. So I have enough distance from your friends, so I don't have to put on mask, but they'll have mask. So you guys that are in the class, including you, go to page 37. I put links for download and installing. Just download it ahead of time so I can help you more. If you have Mac, don't need to install the third one. And when you download, just click next, click everything. So it's very straightforward. So because it takes like 30 minutes to install. So for your friends, I cannot help them that much. But for you guys, if you download and install it, I can just go further and help you guys. Okay, I hope you guys are healthy and safe, including your friends that are in the class. Please take care of healthcare measures seriously. I heard that some schools in Indiana shut down because of too many students got corona. Also, I'm from Auburn University. Yesterday, in the first test, 200 students got corona, and also Georgia Tech, which my brother is a student, 50-something got COVID-19. I mean, for you guys, most likely it doesn't. It's not too serious if you don't have any issues, but you don't want to go like grocery shopping and kill somebody else who might have very old or fragile body. So we take it seriously. Even Usain Bolt got the virus, but he's a very healthy guy. It didn't affect him, but he doesn't want to spread to others, so he quarantined himself. So even your body, you have the most strong body, you need to take care of the others. So, okay, let's keep working on the concepts. And today we have our first lab. Today we have a technical issue. For the slides, please open your system. Because if I want to teach your friends, I need to see it on my monitor. For next class, I resolved it ahead of time, but I'm not sure what happened today. So, go to this. Yes, start from, you can see a slide from Zoom even. But for the good thing you're in the class, I can help you for the lab. Okay, so we talk about challenges in the big data era. We have big volume of data, many variety, many formats, and also the velocity of the data. We have a velocity related to creation of the data. We need a way to handle it. Also, not just handling, your whole of measure is based on the value that you can get from the data. Like if you want to stay in this industry the rest of your life, you need to analyze the data and get some value. So on top of managing the data, you need to know how to process the big data. And the whole goal of this course is these two main parts. First, how to handle the big data and how to process them. So the value that you can get, you might see, you did, so far you did some projects, and in those projects, most likely you did some prediction about the production, market analysis, fraud detection, so on and so forth. So when you have more data and you need more computing power, probably you need to scale your system. First, a system that can handle more data. Second, can handle a ton of process. What I mean, the ton of process, not, even, for my PhD dissertation, I use a supercomputer, not just a very fancy computer. A supercomputer is state of Ohio. But even for the companies like Google, Amazon, Facebook, Yahoo, for them, even one supercomputer is not enough. And they need to have their business keep running. So if you look at page 8, I put a picture of a 5 megabytes RBM hard drive. This picture is taken in 1956. Even that time, they had such an issue. They wanted to scale data from 5 megabytes. Now we are talking about probyte, not megabyte, gigabyte, terabyte, probytes, and even more than that. That time, handling a machine with 5 megabytes hard disks cost $35,000 a year. It was even very hard to move it. Look at the next slide, which is about the capacity and associated costs. In 1997, 2 gigabytes of memory cost $157. In 2004, 200 gigabytes of a hard drive was just $1 per gigabyte. And 2015, 3,000 gigabyte hard drive. Look at the cost. So cost per gigabyte in 2015 is just about a quarter, and now even it's cheaper. Let's see what happens at the end of 2020. But so as you see, scaling your hard drive is not very difficult, and it's kind of cheap, much cheaper. But the processing power is still expensive. So what happens if you have too many data? You just buy more hard drives. That's it. It's not too expensive for a company. It's nothing. So we see that we can easily scale our hard drive capacity or storage capacity, but look at the transfer rate that we use it for reading hard drives. I mean, in 1997, it was 16 megabytes per second. In 2004, it got 4 times faster, almost 4 times faster. But the hard drive capacities got 100 times more. In 2015, a fancy computer had 3,000 gigabytes, but the reading rate was 210. Again, 4 times more. So for reading a 3,000 gigabytes of hard drive, it takes 4 hours. So as you see, the reading rate is not that much more than a capacity rate, increasing the capacity rate. So what happens now? You want to, let's say for a project, you want to read 3,000 gigabytes of data. You want to read, analyze it, and get some, let's say prediction, just a simple prediction. So if you have a business, you can you can use 4 computers. If you use 4 computers in parallel, you can increase your reading speed 4 times. So instead of taking 4 hours, it takes 1 hour. So if you have a good business, instead of 4 computers, you can get like 40 computers. So it's even 40 times faster. As you see, the capacity price or storage price is not expensive. Even 2015 was a 1 quarter per gigabyte. So you can have multiple copies that from now we call it redundant copies, because 1 copy is enough. But for reading, for working parallel, we just make redundant copies. And since the redundant copy is cheap, we don't care about the price. So as you see, when you have big data, you can have redundant copies and read those copies independently and in parallel, and you expedite your process much more. So one way, just make those redundant copies in one location, and you have a large supercomputer. What could be the issues? Rihat, do you remember? I want to process faster, so I make redundant copies, let's say in one large building. I make a supercomputer and process use 40 processor to just process one data in parallel. Huh? Yeah, privacy could be is an important thing, but let's say you're working in Amazon and Amazon asks you. Actually, one of my classmates hired in Amazon, and they have so many data analysis processing. Let's say they have a supercomputer in, what was their center? It was a city in, I forgot the name of the city. It's in the West Coast, Seattle. The headquarters. Yeah. Let's say they did a large supercomputer in their headquarters. Suddenly they lose the power, so they're out of business. Or some, let's say they, instead of Seattle, they are so rich that they buy World Trade Center and make a large supercomputing center there. What if a crazy guy hit by airplane, hit the building by airplane? Which is very unfortunate, but the thing, they get out of business. They cannot work anymore because they lose their computing center. Or a virus, if you're talking about security, somebody have a breach to their Seattle supercomputer center, and they are done. So they don't. So even you have enough engineering power and you have to reach to design by yourself. You know, same as car. If you design one car, it's very expensive than just buy a commercial car. Those commercial cars might be very good, but since all designed for millions of people, it's much cheaper than asking someone to just design a car or make a car for you. So for these two reasons, first of all, it's very expensive to have a very advanced large computing center. It's too expensive, but it's doable or feasible in some aspects, but it's not safe and it's not logical for a business. You, instead of having a large computing center in Seattle, they can make 100 smaller centers around the board. So even half of them got broken, they can handle the business with half of them. Even if there's security issue in 2 centers, they have 98 more centers. So, and also they can use commercial computing nodes or clusters. They are still expensive, but much cheaper than designing something special for Amazon. So they design those 100 is cheaper and much more logical and a safe option. So it's the reason people are doing distributed computing. First of all, they can make 100 copies of Amazon data everywhere. And as you just look at the gigabyte per dollar, it's just not too expensive. And also is a much more, first of all, it's much more economical option, and also it's much safe and logical. But in this course, you learn 2 things. First, you learn some codes, how to manage the data. Let's say you got hired with Amazon and you need to do some customer analysis, whatever. So you need to know what are the codes to ask to just get the data from all the centers first. And also you need to learn something on top of Python. We learned through Python that how to do machine learning over that. So still, you know, you need 2 things. First thing is kind of similar to SQL. Is the reason I told you just review some small things about SQL Server so you can remember something, or you don't have to be an advanced SQL programmer. I just need you guys to have some general ideas about the SQL Server or MySQL, any online courses. If you spend like 4 or 5 hours every semester, you have time, so you can, it's more than enough. For Python, you need to remember some of the things that I told you in the Python course, analytics programming. So we use these two. I don't evaluate your knowledge in Python and SQL, but you need those two for doing your project. So basically, in your project, you understand how to manage the data in from multiple sources, how to change or add something in your Python code to be able to analyze those data. Any questions so far, even for the friends that are the online session? Okay, cool. So I'm talking with your friends that are in class because I should look at them. It's weird for me to look at the monitor, but if you guys have questions, you can ask me too. Okay, let me go to. Okay, if you look at slide page 14, you see the general figure for distributed computing processing pattern. So in that one, we have some storage node and some processing node and a node that manage all the data. And as I already said, you have multiple centers around the country. So everything is through cloud. So you run code through the cloud, and you get the result through the cloud and just report it to your manager or somebody who needs that report. And again, in this course, at the end, hopefully we have time to work in using Amazon AWS. Hopefully I managed that we have enough time for that. But for the learning curve, which takes a lot of time, we use Hortonbox data platform. There is multiple reasons. First of all, you don't mess up, even if you mess up everything, you can just install everything from scratch. It doesn't, but it won't hurt you. And I teach it through a virtual environment, again, because it's same if you either use Windows, Mac, it's same for everyone. So you can even help each other. But as I said, if you can install Hadoop and Spark directly on your system, and I gave a bonus for that. So, and it's a good learning, but you don't have to do that. And at the end of semester, when you get enough knowledge and you have good hands-on experiences, we work with the Amazon AWS, which if you get hired in a like mid-sized company, usually they don't buy cluster or like computing powers by themselves. If in their small or mid-size, they use some. They usually use AWS. So you work with the Amazon AWS, you work their Hadoop and Spark and those multiple things. Another thing, there's a limitation for using AWS. As a student, they give you $100 credit. Even if you forget to turn it off, they might charge you $1,000. They just charge it with the amount of the time that you use it, and it usually happens. But all the time I've seen that they forgave students, but I'm not guaranteed that. So, but for learning how to code Python and how to do something similar to SQL for Hadoop, you don't need to work with the AWS. The earliest part is through VirtualBox, and it's the only thing that you need, the early parts. But when we go, yes? If you can directly install it, that's enough. Yeah, it's enough. Yeah. Yeah, but for learning, I teach through virtual drive because you don't have enough time to just like figure out your issues in Mac, Windows. If somebody uses Linux and many people use VirtualBox. So it will be 4 options, and usually I don't have time. Even the issues might be different. It's hard for me to memorize, okay, this error, what happened in Windows? What does it mean in Windows? What does it mean in Mac? What does it mean in Linux? So there's so many options. So for teaching, I use Horton data platform in VirtualBox. But if you learn how to install and use it, you have a really good learning. It's really good. And again, it's a graduate level course, and many of you, at least half of your learning comes from your own effort. And I recommend to install it on your system. The bad thing, I mean, not a bad thing, actually, it's a good thing, but one of the things, if you mess up anything with your operation system, you need to do something like even refresh your operating system. For me, I mean, a couple of days ago, when I wanted to run some script, I had a typo and I messed up with my operating system. Now I need to refresh my operating system. And this system is owned by Clark, so the issue that I have right now, they don't give me permission to just refresh everything. It's very harder to, but for your own system, you can install even your operating system from scratch. But so in VirtualBox, even if you have the worst mistake, you can delete the VirtualBox install it again. Just take a half an hour or 1 hour at most. But at the end of semester, I mean, it doesn't matter you install it directly. If you install directly, your learning is much better. At the end, you go to a real deal, which is working with AWS, which most likely if you get hired in a company. I think I told the story. My brother is hired in Apple, but he started from a small company, then a mid-sized company, now a large company. So usually in small and mid-sized companies, they use other services like Amazon, Google. So you learn the deal through the Amazon AWS. Okay, so what happens if you do? If you look at page 16, what happens if we do distributed computing? So first of all, for distributed computing, you need to have redundant copies of your data in different computing center. So one issue, how to manage them. Another issue, how to do parallel processing. Another issue, your friend talking about security issue. What happens 2 of your nodes got broken for security or power or anything, or any random errors? So the good thing about Hadoop, Hadoop manage everything for you. So basically, let's say 2 of your nodes are not working, Hadoop just use other nodes. Or let's say you want to divide your data in 10 different nodes. Hadoop just talk with those nodes and say, okay, all of you have the complete copy, but you use first 10%, use second 10%, 20, 30. So it divides everything for you. And if there's any issue in like errors, just Hadoop manage it through some, there is some technology inside Hadoop that just handle the error for you. And at the end, it just get all of the result and aggregate in one report. So you use Python to tell Hadoop to do that, but at the background, everything done by Hadoop. And Hadoop is developed by Java, but through Hadoop streaming, you don't need to learn Java. You can use Python to connect to Java inside Hadoop to do everything. You can spend time to learn Java, but it's not what I recommend unless you, let's say for rest of your life, maybe you work in the Hadoop environment, maybe you can spend good amount of time for learning Java, so directly you can communicate with the Hadoop. But no issues, I mean, Python is more than enough. And machine learning in Python at the end, I think is much better and much more libraries available. But if you remember in the analytics program I taught you, I used R to run Python and Python to R. So if you learn one programming language, you can just communicate with others, call it something inside the other language. So it's not difficult actually. So in slide page 17, I'm talking about what is Hadoop, Apache Hadoop. Apache is a project. Basically, Hadoop first developed by first basically designed by Google. They had a technical paper talking about Hadoop ecosystem. Then at that time, Yahoo was a much larger company, so Yahoo is the first developer of Hadoop. Then it came through Google, and now Apache open source project is a project that's handling Hadoop. And basically, again, it's two parts. First part, how to manage the data, and how to run the codes and aggregate your result in the one report. One more thing, from now, I don't say aggregation, I say reduce. Reduce is a technical term for aggregation, and it makes sense. So you have, you do computing in different nodes. Instead of saying we aggregate in one report, we say reduce in one report. I think aggregation is a better term, but they use, the reduce is a technical term for just aggregating results from multiple nodes. So, and a technology that does it, I mean, or the methodology is, they call it MapReduce or map shuffle reduce. Basically, map means telling each node to work on which part of the data, mapping through different nodes. Not, let's say I'm and there isn't some technical term. Let's say I'm name node. Name node means the node that makes those decisions, is the technical term for that, and your data nodes. Now I want to map the data. I tell you first, you first 30%, you process first 30%, second 33%, the last 30%. So I'm mapping to you guys. All of you has the complete data, but when I do mapping, I'm telling you to just work on first, second, and last 30%. They call it mapping. I see some of your friends are just joining. Please, I mean, be on time next time. So, but you know, the class is asynchronous, so later you can just watch the videos. No worries. So, again, have you guys had a SQL Server before or MySQL course? Yes? Did you have MySQL course before? So, do you remember we had a key? Key means if you have a record of the, how to identify each record. There's a unique number. So there is something similar in Hadoop. We have key and the data or value. So what happens, let's say I want to work with the Clark students' data through your U3 data nodes. I'm name node that map the data to you. So you have 20% of the SOM students, School of Management, you have 50%, you have 20%. And I want to get report based on each school. What happens, the key is SOM, 20, 50, or 30, 50, 20. So now I wanted a report for a School of Management. Now you shuffle the data and then sort based on the key. Because I want to get the data, let's say I want to, let's make a funny example. I want to sum up the weight of students in the School of Management. It's the funniest example came in my mind. So you have the first 20%, 50, sorry, 30, 50, 20. And the key is the SOM, the value is their weight. The sorting part, for the sorting part, I just put all of the SOM student to her node based on the key of SOM. It's weird, I know it's different. I'm showing a better example, but it's just saying that on each node, I just want to process one school. So a School of Management here, a School of, let's say, Science, huh? SPS, or another school, let's say IDC. So we already have the key for each school. I just said this node for a School of Management, this node for SPSS, you said? ICD. So, Yeah, I know what is going on in each node because I already divide the data. Yeah, something similar. I have a better example on your slide. Mhm. So basically, we call it sorting based on key. So, but usually it's a general term is MapReduce. Map the data to the nodes, sum the weight, and reduce the report or aggregate in one report. Let's look at a better example later on. So if you look at page 22, you see the first HDFS architecture. HDFS stands for Hadoop file system. There's a name node that has metadata. Metadata means just information of data. So it's not it doesn't have to hold that data. Maybe something like column names or something similar to that. And there's another data node which has the actual data and do all the computing. There is older names. Sometimes instead of name node, they call it master, and instead of data node, they call it slave. I don't like these old names, but now people use name node and data node. Also, when you want to install Hadoop manually on your system, you need to create some folders with the data node and name node. Just you can right now you can understand the data node means the nodes that folder is for actual computation. The name node folder is for the node. It has the data for the node that just map the data and reduce it. So I'll just skim through the next slides, because in the next slides, I mean, you see the general commands of, like in page 23, you see that general command line of Hadoop. No worries, I mean, I teach it later, but as you see, the first one is Hadoop FS. It's just telling that this is a Hadoop command. And look at the second one, Hadoop FS /mkdir/reports. Hadoop structure is very similar to Unix or Linux. It's inspired by Psycho. What is Psycho? I never heard of that. Oh, MySQL. Okay. I can say it's more similar to Unix and Linux. Yeah. Actually, even there is some graphical interfaces. So for some simple routing works, you don't need to write the scripts. There is something you can do visually, but yeah, inside the Hadoop ecosystem, there's some technologies that you work with the data is very similar to SQL. So if you look at the second code, is mkdir is basically similar to Linux. Mkdir means stands for make new directory. So it makes directory of reports in your root directory through the Hadoop file system. So no worries, I mean, we worked through all of them. I just want to show how it looks like. So at the end, you have two approaches. One approach, you have a graphical interface, which you can do most of the routing works. But also you have command line, which you work with the more advanced option. The thing that even in Windows and Mac, like 99% of the time, you don't need to open the command system because they already made a very good graphical interfaces that manage many things. But even in Mac and Windows, when you have very advanced jobs, you need to script in the, you need to type a script in the command prompt or terminal. The reason for that, I mean, it's not very economical to make a graphical interface for all the commands. They made graphical interface for almost everything, not everything. And Hadoop is not like Linux or Unix. It's not an operating system. It's just inspired by Unix. You can see some commands like get, put, is, if you already, and you don't need to be a Linux expert. In this course, I don't expect you guys. It's good to gradually learn some Linux commands. If at the end of semester, if you have time, hopefully I show you how to connect to a cluster using Linux commands. But if you get a job in the company, sometimes you need to, not very advanced Linux command, at least you need to know how to submit a job to a supercomputer, how to get the results back. There are, I mean, first might look scary, but then it's not like more than 10 commands that you need to memorize. Okay, MapReduce. I'm showing a small video, and for you guys that are inside class, you can hear the voice, but I'm not sure what, there's some weird technology issues. So your friends that are online, they cannot hear the voice. So if you are using asynchronous or synchronous options, please listen to the video later on your convenient time. So let me just open it. The issue, how do I just turn it? Even for you guys, it's hard. Could you see through the Zoom? Okay, so let me just, I'm sorry, I mean. Oh, okay, let me play again. Okay, let me stop the video. So we have a bunch of cards that we want to sum up the numbers that are on top of the cards. And so here we ask for students to have same exact cards. So we have basically 4 copies of the cards, but for each of them, they just focus on certain number of cards. So we map the cards portion to each student. I'm not sure, is it the Zoom issue or a technical issue of today, but let me go to so as you see, the MapReduce is the technology behind Hadoop. The good thing is about, it makes sense, it's straightforward how to divide the data, is very flexible and error tolerant. So if 2 of the nodes or 1 node has an issue, Hadoop can do MapReduce by just 2 nodes. So instead of, let's say you don't want to work, you got tired, and we have 2 other students, instead of 30, 30, 30, I divide by 50, 50. So MapReduce can handle if there's issues in one specific node. And very scalable. Let's say our process is very hard. We can ask, here we have limitations, but let's say we have more students, we can just, if we have 10 students, I just give 10% to each. So if you It's the way that you can handle much more larger data. And later in this course, I'm not sure if you have time next class. Next screen sharing is paused. Let me see. Hopefully, if time in the next week, I teach you some Python code to do MapReduce. I mean, basically Hadoop does it, but in the Python code, you tell Hadoop how to do that. So look at page 29 of your slide. Here, we have employee and their sale amounts. As you see, for example, for Alice, we have 4 records. For Bob, 2. For Carlos, we have 2. So our work is we want to sum up their sale. So what happens? First of all, we have a data with 10 records. This goes from 0 to 9. Then we have multiple values for multiple persons, and we want to sum them up. So what is the key variable here? If you could you recall from the friends that are online, you can answer my question too. What is the key in this data set? What is the key variable? Is the employee name. Because when I want to, it's kind of different from, there's a difference. In SQL, the key means unique. So the unique variable actually is the sale ID. But here, I'm just, key here, what I mean from key, how to identify sale for each person. So it's 2 names, yeah. So, yeah, there is some difference. The difference in key here means how to identify like each sale, each value here. So in the next slide, you see that we have mapping. We just randomly divide data into 4 different nodes, data nodes. So each data node has the complete data. We already made redundant copies, but each node doesn't process all the data, just processes a certain part of the data. So we call it mapping. The next part is shuffle and sort. As you see, we sort based on our key, which is the employee name. So now all of the Alice, all of the Carlos, all of the Bob, and Diana, all of them sorted. The last part is reduce. So basically, we aggregated a sale of each key in a 1 report. Any questions so far? Mm-hmm. Uh-huh. Yes. So does it first randomize and then split according to the key, or? It's already randomly collected, and then when it divides it, it doesn't care about the key, just random set, first 25, second 25. Yeah. Yes. The next step is just sort based on the key, which is the name, then aggregate or reduce. Let's say reduce from now, because the technical term is reduce. There is 2 general Hadoop structure. We work with the second one. With the first one is more simple. We just have a data node, and we have so many name nodes. Data node is kind of like a brain that knows everything, where is each data in which part, and manage the data nodes. However, there is a technology they call it yarn. In yarn, which stands for yet another resource negotiator, is a technology for basically negotiate with all of the nodes and just divide the data there. I mean, basically, on top of the data node and name node, we have application application node, or which is on master. And actually, for each application that you run, you make a basically a node to manage that application. Again, these are under hood, and it's not the case that you need to take care of that much. Just know that you do MapReduce, you may ask Yarn to do that, and Yarn just make an application node, data node, name node, and just manage all the work through that. So we are in the first lab, page 37. Okay, please click on the first. Hopefully, you in the class already did that. So click on the first one, which is VirtualBox. Let me. Okay. Then hopefully you guys see that. So VirtualBox is, you can consider as a virtual PC that you can install everything in it. If you download and install VirtualBox, you can even install Windows, Linux, even you can any operating system. But for this course, we install Horton Sandbox, which is a pre-installed Hadoop platform. The good thing for the learning curve, we don't want to just face too many issues. We just want to be more straightforward. So based on your system, you click on the operating system. The first one is Windows, then Mac OS, Linux. So I click on Windows. The rest is very simple. You just click. Where's my mouse? And just next, and you install it on your system. For Mac, installation is a little different. I know you guys who knows Mac, you know how to install it, but just do everything based on defaults. Okay, the second one is for installing HortonBox Hadoop platform. You can select VirtualBox, VMware, or Docker. Please choose VirtualBox. That would be same for everyone, but if we can use other options too. VirtualBox, start. Then you need to provide your information. So email, university, and just click everything. Oh, there's an error. I'm not sure where. Oh. So we have two options. Hadoop Sandbox 3, 2.6.5 and 2.5. If your system is very fancy and very new, you can use Sandbox 3. If your system very old, it's 2.5. But it's kind of in the middle, use 2.6.5. It's the version that I teach for the class, because I know that almost all the systems should be able to run. Doesn't need that much requirements. So it's the version that I use for this class, but I mean, if your system, if you feel that your system is too slow, you can switch to 2.5. But you might face different errors if you all of you use 2.6.5. Hopefully, you can help each other. So it will be the same for everyone. But if you click on it, the download is starting, but you know, it's 15 gigabytes. It takes forever. You can, what I do, you know, maybe you're in the location that your system is not stable. Suddenly when you download 10 gigabytes and suddenly it stops. And you need to start from scratch. For avoiding that, a safer option is just right click. Is copy. Today's difficult. Copy address. Then use the download manager. So I'm using Untitled Download Manager, but you can use any download manager. There's so many free options. So you can add an OK and download it. So in later, if you have any interruption in your internet, you can resume the download later. So I recommend to use a download manager for download that much of large data. But I think the universe in Clark, it took like 15 or 20 minutes for me to download it. So you can start downloading. Okay, after download is finished, so for you guys that are in class, you can download it and later I show you something. But so let me just show my. Okay. Where is my mouse? Okay. Then it should be the shape of your downloaded file. You click on it. Please see from Zoom. I cannot drag it at this time. Could you guys see the virtual drive in my Zoom? Could you see that? Okay. So as you see, it said Oracle via. Huh? Let me see. Okay, let me put on my mask. Where's my mask? So okay, so when you after downloading, you see that it for me says for CPU 10 gigabytes of RAM. If you can just leave it 4, but for the RAM, you can change it to, let's say, if you have like 80 gigabytes of sub RAM, let's make it 16. Or if you have 14, make it 12. So you should know the maximum RAM in your system, make it a little less than that. Then the next thing is just import. And it takes a lot of time because now VirtualBox tries to download so many files. So it would take a quite amount of time to finish it. So for you guys that are in class, this is like, so you guys that are in the Zoom, could you hear me with the mask? Let's see.
Yes.
Okay, that's good. So look at here, in front of my RAM is 16. If I want to change it, I just click on it, then increase it maybe like to 18 or 16 or whatever. So in front of RAM, there's a number, you can click and just change. So that's it, and then when you look at your VirtualBox, you see I have Horton Sandbox HTTP 2.65. When I double click it, now you can see that my Horton is running up. Now it Hadoop is coming up. So if you look at, let me just drag it here. So the guys that are online, do you see there is a local host in the black screen? Could they see? Yeah, I think one of your friends said yes. So we have VirtualBox is the first option. This is the address that you need to type on your browser to get to a graphical interface of Hadoop. So for the graphical interface of Hadoop, just type HTTP / localhost 1080. So when you type that address, you get to Hadoop. So let me just do it. Okay, so I type localhost 1080 and I get to this screen. So in the when you click the first one, so you see an option to sign in. Your username and password is Maria_DEV or Maria Dev. You need to put these two for username and password, then sign in. And now is a graphical interface of Hadoop. I told you that you can do many things here, but from some advanced option, we need to do command lines. For the people who are online, I know that it takes might be 1 hour you get to this point, but sometimes you get some errors. So if you face any problems, just post over GroupMe or email me. I reach you guys and answer your questions. You see some red alarm here. It means it takes time to fully load it. So it's the reason some of them are not loading yet. So it's the reason you see some red sign means they're still working on it. It's very common because it's a really huge system that needs a lot of resource. Okay, that's for today. And please look at this, the remaining of the slides. There is some conceptual things that you need to review for understanding some other technologies under Hadoop. Hopefully from next week, hopefully, I'm not sure if we have time, by the end of next week, we start coding in Hadoop and do some Python scripting in Hadoop. Okay, that's for today. For you guys that are home, if you have Windows, please install Putty too. Let me just go there. Putty is enable command prompt in Windows. For the people who are using Mac or Linux, they can use their terminal, but for the people who are working Windows, for getting to the similar terminal, you need to install Putty and work through Putty. And I teach you later how to do that, but please download and install Putty too. Okay, thank you very much. That's for today. See you guys next week. Let me just stop sharing. Oh, sorry. Is there anyone with a question? If you have questions, still have a few minutes. Okay, I don't see any questions. So let's just finish for today, and I upload the material later because I know it might take a significant time to download and install the platform. So, but no worries. If you have questions, some of your friends said couldn't install 2.6.5. It's really weird. And I mean, you can work with the HTTP3. It needs more hardware. Please retry. If you couldn't do it later, just email me and I work with you to find the problem. I can give you a link later. So let me give you the direct link for Hadoop 265. And if it didn't work, I post the link in GroupMe. If it didn't work, just go to 3. But for 3, I mean, you need much more fancier or complex hardware. Okay, thank you very much. Have a great rest of the week.